Okay, yeah. Take 50, I guess. So we're gonna do FRQ 1, and this time we're gonna do Model E, right? So again, what we're gonna focus on is a graph, right, for function f. So in this case, it's asking us to follow through. It's always gonna ask us for FRQ1 to follow through with the composition of functions. So I'm gonna have h of x equals g of f of x. So in this case, you need to focus on the input. The input given is 3. So inside parentheses, 3, 3, whoa, 3, 3, right? So we don't need this no more. We're gonna get rid of it for a bit. So let's focus on function f and 3 because we're going from right all the way to the left. So an input of 3, follow the graph. Is it above the 3 or is it below? Well, it's above it. So as you follow through, once you hit it, go to the y-axis and get your output being 2. See ya. Thank you guys.
Thank you.
So here we're gonna have g of 2. So now what you have to do is look at the function g and try to graph that in decimals. So when you graph it, right, which in our case, we already took the time to do that. We're gonna go here. Once you graph it, go into another row and put g of 2. And the answer should be x equals 4.079. So that was A1. What about A2? What does it ask us to do? Let me scroll down a bit. So for A2, it's asking us to find all the real zeros of function f. So zeros are when the graph, whichever graph is given, touches the x-axis. In this case, if you follow the graph from left to right, we hit or was it? Where is it? Find out the zeros, right? So we hit it right about here, and then we follow through, and we go back. That's the only time we only touch this x-axis one time. So my answer for A2 is x equals -1. So now, for part B, find all the values of x as decimal approximations for which g of x equals to e. E representing Euler's. So if I go back to decimals, because for decimals, we graphed g of x. And now it's asking us to graph g of x again, right? So we need to see where they intersect. So going back to decimals, I'm gonna create a new function. G of x equals e. And e is just basically a constant, right? A constant of 2.71, something like that. So where do these two graphs meet? So these two graphs meet, let me zoom out just to double check. Alright, yeah, these two graphs meet right here. So that would be your answer. Your answer would be 1.270, right? And if you want to keep on putting the numbers after decimal, all the numbers, go ahead and do so. Alright, but we only need 3. So that's your answer for B2. I'm sorry, B1. Finally, determine the end behavior of G as x is increasing. So let's prep it. So I need to do limit notation. So for limit notation, I would put limit x approaches, and that's right here. X is increasing. So x is going to positive infinity. What's happening to g of x? What's happening to the y? As x increasing, is increasing. So going back to decimals, because we're focused on g of x, let me get rid of this. You'll realize that Even if I zoom out as much as I want, right? Already in 2000s. Look at the y's. The y's are slowly but surely increasing. So there's no asymptote here. What this means is that slowly but surely, this function will, at least for the y, as x is approaching positive infinity, will continue to go upwards. Meaning that g of x will go to positive infinity. Unless the y is constant, that means there's an asymptote. But in our case, it's not constant. So there it is. Where am I? So now, let's focus on part C. For part C, does f have an inverse? So let's go back over here. Alright, so for C1, does this graph have an inverse? So what you have to do here is, again, you have to place a horizontal line test and test it. Horizontal line test, these horizontal lines are supposed to touch the graph exactly one single time. So, does this function have an inverse? Yes, it does. Yes, it does.
I didn't say no, I said yes.
Repeat with me. Yes, it does.
Yes, it does.
Damn, tough crowd, tough crowd. So, yes, function f has an inverse. Alright? So, explain yourself. Always explain yourself. Why? Why is this possible? Yeah, you can say function f passes the horizontal line test, but that's not good enough. Yeah, you can say it's 1 to 1, but that's still not good enough. You have to specifically state that each unique output has one unique input. Ta-da! That's it. Good luck.